They called it nothing more than an ODD sonar blip. But what was found deep in the Bermuda Triangle was immediately restricted, and most people never saw it. It was not random. It was not natural. Access was limited almost immediately. Multi-beam sonar does not just scan the ocean floor, it slices it open, layer by layer, with a fan of sound. Picture a ship crawling across the open Atlantic, firing out hundreds of acoustic beams in a wide arc beneath the hull. Each ping races down, hits the seabed, and bounces back. The time it takes for those echoes to return tells us the depth, down to a margin of just a few meters, even when the water is miles deep. But there is a catch. At 3,000 meters, the sharpest systems out there can only resolve features bigger than about 30 meters across. Anything smaller starts to blur into the background noise. That is the hard limit. Every beam in the fan is tracked by a precise grid, bearing, angle, and arrival time, corrected for the ship's roll and the ocean's shifting sound speed. The data is then stitched into a color-coded mosaic, a digital map of peaks and troughs. This is not a camera. There is no light, no color, just the cold certainty of physics. If something organized appears in that return, it means the pattern is at least as large as a city block. Natural seafloor is messy, chaotic, random. When a sonar image suddenly shows straight lines, sharp angles, or a repeating grid, it stands out. That is not supposed to happen. When that happens, hydrographers notice. Because in a world where 30 meters is the minimum pixel, anything that looks organized is either massive, manufactured, or a trick of the data. And when the anomaly in the Bermuda Triangle first appeared, it should not have looked like this. If you enjoy uncovering hidden truths and shocking discoveries buried beneath the ocean, especially those linked to the Bermuda Triangle, subscribe now, because the next mystery we are revealing might be even more astonishing. Coordinates 31.5 degrees north, 65.4 degrees west. In the middle of the Bermuda Triangle grid, a sonar return came back that did not fit any natural pattern. On the screen, not a random scatter, not a messy slope, but a lattice. Straight lines, sharp angles, a geometry that stretched for kilometers. Each ridge, spaced almost exactly 90 meters apart, cut across the seabed at a near-perfect 45-degree angle. The elevation difference was a clean 12 meters from peak to trough, repeating in a way that looked almost engineered. Hydrographers flagged it instantly. The data tile, NCEI Atlantic MBES 2016 31 and 65 WW, showed the grid holding its shape across 3 separate sonar passes. No sign of a processing glitch, no obvious artifact. A feature this organized, this big, is rare even in the world's most volcanic terrain. Dr. David Gallo, a senior scientist at Woods Hole, put it bluntly. Sonar shows us contrast, not intent. Many linear returns we see are simply the shadows of natural slumps or the edges of pockmarks, not hidden bases. But this was not a single line or a scattered cluster. This was a hexagonal lattice, 4 square kilometers wide, etched into the abyss. No shipwreck, no known test rig, no natural ridge in the public record matches the precision of this pattern. The sonar did not just capture a blip, it captured something that looked deliberate. And that's when the questions started. Why here? Why now? And why, almost immediately, did access to this area start to tighten, become restricted? A single letter, stamped with the Navy's insignia, arrived at Atlantis Deep Sea Research in early 2021. The request was permission to send a civilian sub-bottom profiler over the grid coordinates. The response was denied. The official reason was potential conflict with classified undersea test activities in the vicinity of a U.S. Navy training area. No map was attached, no further explanation, just a reference to Naval Operating Area 27. The language was clinical, almost bored. Distribution of detailed bathymetric data is limited to authorized government users. A Freedom of Information Act request followed. The reply landed 1 month later, short, final, and just as opaque. The reply said no releasable material exists in the agency's records. National security, they said. There was no hint whether the data was missing, classified, or never collected at all. The trail stops cold. A retired Navy sonar technician, asked off the record, put it this way: If there is a Navy exercise, the data goes dark. Sometimes it is routine, sometimes it is not. But when you see a permit denied for a patch of empty ocean, you know there is more going on than just fish. For the first time, the path to independent study was blocked. The anomaly was not just a curiosity anymore, it was now officially off limits. A digital map of the Bermuda Triangle region, updated in early 2023, shows a jarring interruption. A single tile flagged with a null mask sits like a missing tooth in an otherwise seamless grid. The label in the NOAA metadata is blunt. NOAA 27 restricted operations. Everywhere else the bathymetry is sharp, with peaks, troughs, and volcanic cones rendered in 5-meter detail. But over the coordinates in question, the data simply vanish. The tile is not corrupted, and it is not a technical glitch. It is a deliberate blank, inserted by policy, not by accident. The difference stands out even more when you compare the 2015 and 2023 data sets side by side. The older map shows a continuous seafloor. The new one, for the first time, overlays a mask, no color, no depth, just a void. This is what a restricted area looks like in official ocean science. Not a dramatic red X, but a silent administrative erasure. A Freedom of Information Act response used the same coded language. No releasable material exists in the agency's records for this region. It is the bureaucratic equivalent of a locked door. In a field built on open data, that kind of silence is louder than any rumor. 5 explanations compete for the Bermuda Triangle anomaly, each with its own logic and its own blind spots. First, geology, volcanic ridges and pockmarks. Scientists point to the Bermuda Rise, a volcanic swell riddled with linear basaltic features and conical knolls. But the precision of this grid, straight lines and 90-meter spacing, pushes the limits of what nature usually builds. If it was just geology, why does it look engineered? Second, ancient structures. Some claim the pattern matches lost cities or prehistoric platforms, sunken in a forgotten era. Yet, no ROV footage, no artifacts, and no magnetic anomalies have ever backed up those stories. The depth, 3,000 meters, would crush any ancient stonework. Archaeologists demand more. High-resolution images, physical samples, a timeline. None exist here. Third, wrecks. The triangle is littered with shipwrecks and debris, but those scatter randomly, not in a perfect grid. Historic wrecks cluster near reefs and shallow ledges, not in the deep mid-Atlantic abyss. No known disaster matches the size or shape of this anomaly. Fourth, military activity. The U.S. Navy training zones overlap this patch of ocean. Arrays of sonar reflectors or test rigs have been deployed before, often in geometric patterns for calibration. But nothing in the public record confirms a grid this large or this permanent. Permits were denied and data withheld, but official statements stay vague. Finally, artifact, data in error. Sonar is notorious for tricks, side lobe echoes, multipath returns, and processing bugs. A misaligned swath or a software glitch can conjure shapes that never existed. Yet 3 independent passes, each showing the same lattice, make a pure artifact less likely, though not impossible. Dr. Robert Ballard, the man who found Titanic, once warned, "When you see a pattern, your brain wants to complete it. The only way to know what's really there is to send an ROV to look. No amount of sonar can replace visual confirmation. Until that happens, every theory is just a guess, and the anomaly remains unsolved." An independent analyst loads the raw sonar files, no filters, no smoothing, just the cold geometry. The supposed anomaly, that lattice of sharp lines and right angles, refuses to vanish. Even after the standard de-ghosting sweep, the pattern holds. 90-meter spacing, 12-meter elevation jumps, a grid that lines up with mathematical precision. The difference map, run pixel by pixel, shows the geometry is not an artifact of noise or a trick of the algorithm. It is there in the numbers, not just in the image, but the critique comes fast. Dr. Elaine Kelly, a seafloor morphologist who has reviewed hundreds of Atlantic maps, points to the signal-to-noise envelope. She argues the difference is barely above the background, less than a meter in many spots. Kelly's verdict was that natural sediment drifts and fracture fill ridges can mimic boxes at this scale. The sharpness you see is a side effect of how the de-ghosting process exaggerates edges. She even reproduces the effect on a control tile, turning a modest ridge into a near-perfect rectangle with a single processing tweak. So, which is it? An engineered relic hidden by policy? Or a ghost conjured by the limits of sonar and the human eye's hunger for patterns? The geometry persists, the experts disagree, and the data sits in limbo. If you are fascinated by forbidden discoveries beneath the sea, especially those that governments do not fully explain, subscribe now. The next underwater mystery we are uncovering might shake what you think you know about the ocean. Right now, the official sonar data from this site is still withheld. It is one of dozens of deep ocean records marked restricted on public maps. As technology makes the ocean less mysterious, secrecy only grows more obvious. The real question is, what else lies beneath, hidden by silence? Drop your theories below.